In the diagram below, AC is equal to 7.2 and CE is equal to 2.4. Which statement is not sufficient to prove triangle ABC is similar to triangle EDC? So to prove triangle similar, let's just maybe list out some of the ways that we can go about this, and then from there we can determine which ways are not sufficient then, right? We can certainly prove triangles are similar using angle-angle theorem. We can prove triangles are similar using a side-angle-side relationship, where we have two pairs of corresponding sides that are proportional, while at the same time one corresponding angle congruent. We can also have a side-side-side similarity, where all three sides share the same proportional constant, where all three corresponding sides are proportional. And actually, that's about it, because if you consider ASA similarity, right, well, that's just angle-angle, right? And if you have angle-angle side, well, that's also just angle-angle. So really, there's only three different ways of proving triangles similar. So what are the ways that we cannot prove triangles similar? Well, we cannot prove triangles similar, once again, if there's an ASS, angle to side relationship, or SSA. So if you have two corresponding sides, two pairs of corresponding sides that are congruent, and then the angle that are congruent is not the angle that's the included angle, then what will happen is you cannot justify that the two triangles are similar. Okay, so we're looking for something like this, okay, involving angle side side or side side angle. Again, this question is worded kind of weirdly. It says which statement is not sufficient to prove. This, if we have an angle to side relationship, angle to side side relationship, right, similarity statement, then that is not sufficient to prove. All the things in here that I'm circling are. All right, so let's take a look. Option number 1, answer choice 1, AB is parallel to ED. This would automatically make all the angles corresponding, and therefore the two triangles are going to be similar. One thing I dislike about this problem, they should also have stated that ACE is a line segment as well as BCD is a line segment, and they both intersect at point C. Why is that important? Well, that's because then we can see that BCD being the transversal, it will then cause, as a result of that, those two alternate interior angles are going to be congruent. Same thing could be said about this, right? So this is under the assumption that ACE and BCD are straight lines and that they intersect at point C. So option number 1 would prove the two triangles similar, okay? So that's not good. Let's take a look at the second option there. Second option, DE is 2.7, so this is 2.7 here, and AB is 8.1. Okay, so what we have now, okay, and again, under the assumption that ACE is a straight line and BCD is also a straight line, then what will happen is, okay, we have a pair of vertical angles, so we have an angle, and if I compare, let's say CE to AC, right, CE to AC, so that would be 2.4 over 7.2, right? Is this going to hold true? Is that proportion going to hold true with 2.7 to 8.1? And as a matter of fact, it does. This is all equal to 1/3. If you multiply 2.4 by 3, you're going to end up with 7.2. If you multiply 2.7 by 3, you're going to end up with 8.1. However, this is not good, because this gives us a angle side side to angle side side relationship. This is not sufficient to prove that the two triangles are similar. So the best answer here is option 2. But let's take a look at option 3, why option 3 does not work. So option 3, if I have CD is equal to 3.6, so I'm going to erase this. So CD is 3.6, and BC is 10.8. Right now, the way that this thing is oriented, I have a side angle side similarity relationship. That is, if, again, 2.4 over 7.2, if that proportion holds for 3.6 to 10.8. And as a matter of fact, it does. If you multiply 3.6 by 3, you will end up with 10.8. So this all equals to 1/3. This checks out. We have a side angle side relationship here. Let's take a look at the last option, why that would also be possibly sufficient to prove the two triangles are similar. Let's take a look at the last option there. And that is DE is equal to 3, AB is equal to 9, CD is equal to 2.9, and BC is equal to 8.7. So if you look at this, 2.9 to 8.7, this is the same thing as 3 over 9, which is the same thing as 2.4 over 7.2. This is all equivalent to 1/3. So yes, that also checks out. This is going to be a side similarity. This one is a side angle side similarity. And this one will give you an angle similarity. So therefore, the only one that works is option 2.